In this problem, it says determine the length of the altitude of a regular tetrahedron with edges of length 6. Now, a regular tetrahedron is a four-sided shape where each side is a equilateral triangle, and we want the height running through the middle of it. And so what we're going to do is we're first going to focus on the base, and we're going to ask, how long is this spot to a corner? That's what we're going to figure out first. So if we draw out an equilateral triangle, flat, this is the spot we're interested in. Now they tell us that all these edges are 6. This is 6, this is 6, this is 6. And in an equilateral triangle, all the angles are 60. But if I break it up like this becomes a 30-degree angle. So we have a 30, 60, 90 triangle. And this is going to fall right in the middle. So that means this piece is 3. Now this is opposite the 60-degree angle. So to get the side that's opposite the 30-degree angle, we're going to take 3 and we're going to divide by radical 3. And over here for the hypotenuse, we're going to double that. It's going to be 6 divided by radical 3. And if we rationalize that denominator, it's going to be 6 radical 3 over 3, which is the same as 2 radical 3. This is the part we care about, because this right here is the length of this triangle right here. And because this is the height of this tetrahedron, we can assume that it forms a right angle. So, off to the side here, this is the height we're interested in. Now this is one of the edges, which we still know is 6. And this is the length to the middle of the base, which we found right here to be 2 radical 3. So, now we just apply the Pythagorean theorem. H squared plus 2 radical 3 squared equals 6 squared. H squared plus, not equals, 2 squared is 4 times 3, that should be 12, equals 36. So H squared, I'll subtract the 12 over, so we get 24. And then we take the square root. Now we can't take the square root of 24, but we can break that up into 4 times 6. So we get 2 radical 6. And there's our answer. And we're done.